Hello friends. Welcome back to Boss School. Today we begin Chapter 2 of Class 11 Mathematics, Relations and Functions. This chapter helps us understand how elements from one set relate to elements of another. Let's explore each concept in depth, exactly as presented in your textbook. Mathematics is about identifying patterns, consistent, recognizable links between quantities. In this chapter, we study relations, which are similar to relationships in our daily life. Just like we say someone is a brother, sister, father, or mother, in mathematics, we define how one element is related to another. Cartesian product of sets. Let's begin with the Cartesian product. Suppose we have two non-empty sets, P and Q. The Cartesian product P cross Q is defined as the set of all ordered pairs, P, Q, where P belongs to P and Q belongs to Q. We write P cross Q is equal to fleur bracket, P, Q, such that P belongs to P, Q belongs to Q. For example, if P is equal to 1, 2, 3, and Q is equal to 4, 5, 6. Then P cross Q is equal to 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6. Important points to remember. If either P or Q is a null set, then P cross Q is also a null set. If either P or Q is infinite, then P cross Q is also infinite. Points to note on Cartesian product. Two ordered pairs are equal only if their corresponding elements are equal. So, 1, 2 is equal to 1, 2, but 1, 2 is not equal to 2, 1. If the number of elements in set A is P, and in set B is Q, then the number of elements in A cross B is P into Q. We can also define ordered triplets like A, B, C, where A, B, and C all belong to set A. This is written as A cross A is equal to A, B, C, such that A, B, C belongs to A. The next topic is relations. A relation A from a non-empty set A to a non-empty set B is a subset of the Cartesian product across B. This subset is formed by describing a relationship between the first and second elements of the ordered pairs. In this context, the second element is called the image of the first element. The domain is the set of all first elements in the relation. The range is the set of all second elements that appear in the relation. The codomain is the entire set B. Note that the range is always a subset of the codomain. Points to note on relations. Relations can be represented in two different ways. First is roster form, listing all ordered pairs. The second is set builder form, describing the rule that defines the relation. For example, R is equal to A, B, such that B is equal to A plus 1, where A, B belongs to A. Relations can also be shown using arrow diagrams, which visually connect elements of set A to elements of set B. The total number of possible relations between two sets A and B is 2 raised to the power, number of elements in A cross B. Arrow diagram of a relation. An arrow diagram shows how each element of set A is connected to elements of set B. Each arrow represents a pair in the relation. Functions. A function is a special type of relation. A relation f from set A to set B is called a function if every element of A has one and only one image in B. This means no element in A is left out. No element in A maps to more than one element in B. If f is a function from A to B and A, B, belongs to f, then we write f of A is equals to B. Here, B is the image of A under f, and A is the preimage of B. We denote the function as f such that A to B. If the range of a function is either the set of real numbers R or a subset of R, it is called a real-valued function. If the domain is also R or a subset of R, it is called a real function. Arrow diagram of a function. In the arrow diagram of a function, each element of set A points to exactly one element of set B. This visual confirms that the relation satisfies the definition of a function. Real functions and their graphs. Let's now explore different types of real functions and their graphs, as listed in your textbook. 1. Identity function. It is defined as f of x is equal to x. Domain is R. Range is R. Graph is a straight line passing through the origin. 2. Constant function. It is defined as f of x is equal to c, where c is a constant. Domain is R. Range is c. Graph is a horizontal line at y is equal to c. 3. Polynomial function. Defined as f of x is equal to a0 plus a1x plus a2x squared plus 2anx raised to n, where n is a non-negative integer and coefficients are real numbers. 4. Quadratic function. Defined as f of x is equal to x squared. Domain is R. Range is 0 to infinity. Graph is a parabola opening upwards. 5. Cubic function. Defined as f of x is equal to x cube. Domain is R. Range is R. Graph is symmetric curve passing through origin. 6. Rational function. Defined as f of x is equal to 1 by x. Domain R minus 0. Range R. Graph 2 branches with asymptotes at x is equal to 0 and y is equal to 0. 7. Modulus function. Defined as f of x is equal to modulus of x. If x less than 0, then f of x is equal to minus x. If x greater than equal to 0, then f of x is equal to x. Domain is R. Range is R plus. 8. Sinum function. Defined as f of x is equal to 1 if x is greater than 0, 0 if x is equal to 0, 1 if x is less than 0. Domain is R. Range is 1, 0, 1. 9. Greatest integer function. Defined as f of x is equal to x in square bracket. It gives the greatest integer less than or equal to x. Domain R. Range Z. 10. Linear function. Defined as f of x is equal to mx plus c, where m and c are constants. Domain R. Range R. Graph is a straight line. Algebra of functions. Let's now learn how to combine functions. 1. Addition. If f and g are functions from x to r, then f plus g of x is equal to f of x plus g of x for all x belongs to x. 2. Subtraction. F minus g of x is equal to f of x minus g of x for all x belongs to x. 3. Multiplication by a scalar. If a is a real number, then a dot f of x is equal to a dot f of x for all x belongs to x. 4. Multiplication of two functions. F dot g of x is equal to f of x dot g of x for all x belongs to x. This is called pointwise multiplication. 5. Quotient of two functions. F divided by g of x is equal to f of x divided by g of x for all x belongs to x, provided g of x is not equal to 0. Important questions to practice. Here are the questions listed in your textbook for practice. Solve these examples mentioned to understand. Examples 1, 2, 3, 9, 11, 13, 14, 20, 21, and 22. From exercise 2.1, questions 1, 2, 3, 6, 8, 10 and from exercise 2.2, questions 1, 2, 6, 8, 9 and from exercise 2.3, questions 1, 2, 3, 5 and from miscellaneous exercise, questions 1, 2, 3, 4, 5, 11, 12. It's recommended to solve every question from NCERT, not just the listed ones, to build a strong foundation. That was Chapter 2, Relations and Functions. We explored Cartesian products, defined relations and functions, studied various types of functions and their graphs, and learned how to combine functions algebraically. If you found this helpful, please like, share, and subscribe to Boss School. The next chapter will be on trigonometric functions. Press the bell icon so you don't miss it. All the best for your studies. Keep learning.